test because some of you guys do that or you don't really put much thought into it. And the problem is that a huge chunk of this test is related rate. So if you skip the word problems, it is possible that's all I'm going to give you. So you'd end up skipping the entire test. So I want to make sure you do understand word problems just in case that's the case. I'm not saying that's the deal. I'm just saying this is a huge chunk of what you need to understand. And math, you guys, the whole reason we study all these numbers is so you can apply it to real life. Real life is the word problems. So that's what the good stuff is. So number 12, we've got a 20-foot ladder. So here's the ground, here's the wall, it's leaning up against. Is that ladder going to get any longer or shorter throughout this problem? No, the ladder's 20 feet. That is a constant. So that means that is a number you get to stick into your equation before you take the derivative. It says that it's sliding away from the wall. And we're going to call this x and y because that makes a lot of sense. So it's sliding away from the wall and it gives you a rate. When you see the word rate or it's talking about a speed or something, what is your brain supposed to be thinking? Derivative. So they're giving us dx over dt, and they tell us that it slides away at a rate of 3 feet per second. And then it says how fast, so what's the rate? They're asking for a derivative. Will the top be moving down the wall? So they're asking about that movement right there, so we don't know dy over dt is what we have just found out. That's what they're asking for. I'm shedding. I can tell I've got hair all over my arms. This is annoying. Okay. When the bottom of the ladder is 12 feet from the wall. So is x or y 12? X. So they're saying when x equals 12. Why is this word when so important? Right, it's not always 12. At some point as this thing slides out, it hits the number 12. But it doesn't stay that way. So the 12 gets put into the equation before or after the derivative? After. And we're not given an equation. What is it? Right. 3 super common problems in related rates are volume of spheres, volume of cones, and Pythagorean theorem. Sometimes they're outside of those 3, but those are kind of the 3 most important ones. So be watching for those. So we have x squared plus y squared equals, I could put r squared, but I'm going to put 20 squared. Because that's our constant. The length of that ladder is not going to change regardless of how fast it's moving or where it's laying. So we take the derivative and we have 2x dx over dt plus 2y times dy over dt equals 400, right? 0. Thank you. 0. First hour didn't pick up on it quite so quickly. 0. Because we're taking the derivative. Question. Do you guys know why we put dx over dt and dy over dt? Do you know where that comes from? The derivative of the inner function. So we've taken the derivative of the outer function, then we need the derivative of x itself with relationship to t, and that's why we have to say dx over dt, and that's why we say dy over dt. So that's where that's coming from. I know some of you, I think, still quite didn't understand that. So let's plug everything in that we know. We have 2 times, they tell us x is 12. They also give us dx over dt, and they tell us it's 3, plus 2 times, I don't have a y. Do we? How do we find it? What do we do? Pythagorean theorem. And so if this is 20 and this is 12, what do you get this to be? 16. It's not always 16, but when x is 12, y is 16. So I'm going to put a 16 here. And we don't know dy over dt, so we treat it like a variable. And now we go back to 8th grade and we just solve. So 12 times 2 times 3 is 72. I'm going to go ahead and subtract that from both sides. Hope that doesn't freak you out. 2 times 16 is 32. Divide both sides by 32. And we can reduce into negative 9/4. And what's the label? Well, that's what we're about to talk about. We got a negative, but you need to look at your question. The question says, how fast will the top be moving down? They have already specified it's moving down, so do you need this negative? No. So in your blank, you would say 9/4 feet per second. If it said, how fast is the top of the ladder moving, then you would say negative to indicate to the reader that it's moving down. Otherwise, it would be moving up. Questions on any of that? Yes, ma'am.
Say, like, on the test tomorrow, if like, we did put negative, like...
I'd, like, count a point off.
Okay.
Yeah, you would miss the whole thing, but I would take off a point.
Do we have to write
The whole sentence? Nope. But the sentence piece that we did a couple of days ago was so you could kind of start thinking about that positive, negative piece.
We're not going to have to do that on the test.
No. Alrighty, 13. 13 is talking about a balloon that's expanding. So already I'm thinking, I kind of probably know the formula. We're probably headed toward what? Which is? If you don't know it today, know it by tomorrow. Volume of a sphere.
Related to the volume of the sphere in the cone.
Mm-hmm. And just in case, I would know the area of the circle is pi r squared. That showed up on one of your assignments. Be ready for that. Also, one of them that showed on your assignment, remember that triangle trough? That triangular prism was half times base times height times the length. You could have a rectangular trough, right? Rectangles, volume of a rectangle is what? Base times height times width. What if it's a cube? Length cubed or side cubed. Yep, exactly. So we've got our equation probably. It says find the rate of change of volume. So ding, ding, ding. We don't know the rate of the volume, so we say dV over dt is what we don't know. That's our question mark. Then it says the radius is, when the radius is 8 meters, so when r equals 8 meters, and there's a typo on this, and it's changing at a rate, so they're giving us the change of the radius, they're giving us dr dt, and the change is 1.5. It says feet per second, it means meters per second. I would read your questions tomorrow. It is possible that we would have you change something from seconds to minutes, or from meters to centimeters. I'm not going to make you go back and forth between metric and standard units, if that makes sense. Like your standard customer units, like I'm not going to make you go back and forth between meters and feet. That would be really mean. So this is going to be meters today. So let's take our derivative of this little guy right over here. So dV over dt. I'm going to take 3 times 4 pi over 3, and you get 4 pi. What happens with the r? R squared. We lose an exponent, and we also need the dr dt. So that we have the derivative of r, which we don't know. Now let's plug in stuff that we know. We're looking for dV over dt, so I'm just going to rewrite it. 4 pi is 4 pi. Our radius they gave us was 8. And tell me again, why couldn't I just plug in 8 at the beginning? It's changing. It's not always 8. As it expands, it hits 8 on its way out, but it's not always 8. And then our dr dt is 1.5. So now it's just a matter of doing some multiplication. 64 times 4 times 1.5. What is that? That sounds good. 384 pi. And what is our label? Good. Why is it cubic meters? Because it's volume. It's three-dimensional. Good. Tomorrow, I will expect really pretty, perfect labels. So I need the sign to be correct, and I need the labels to be correct. Questions? Well, yeah, that too, obviously. Smart aleck. Carson, you good? Okay. 14. All right, let's read. Let's find out what we know and what we need to know. Sand is falling in a conical pile. I'm going to go ahead and draw that picture because I'm a picture person. Sand is falling into a conical pile so that the radius of the base is 1/4 of the altitude. I'm going to translate that. Radius is 1/4. I don't usually call it altitude. What do we usually call it in here? Height. We usually call it the height. I just translated that sentence. Radius is 1/4 of means multiply altitude or height. Okay? The sand is falling at a rate. So what are they giving us? They're giving us a derivative, rate derivative. So they're giving us the, and it says 8 cubic feet per minute. If you weren't sure if it was dr over dt or dv over dt. What's your clue so you would know? The cubic. The cubic tells you that it's the volume. So dv over dt is 8 cubic feet per minute. And then it says how fast, what's the speed, what's the rate, so what's the derivative, is the altitude increasing. So we're looking for dh over dt when the pile is 2 feet high. So when h, the height, is 2 feet. Questions about how I knew what to write up there at all? What are we missing? We don't have a dr over dt, and we also don't have what? We don't have an equation. What is the equation? Good. 1/3 pi r squared h. If you don't know it now, know it by tomorrow. Volume of a cone. Now here's my problem with this. Before I even get started, and you've done enough of these that you kind of know what to look for now. I've got radius stuff and height stuff. Over here, I've got a bunch of h stuff going on. I don't have anything relating to r except for this statement right here. So I probably need to put this equation in terms of h, because that's the stuff they gave me and what we're looking for. Does that make sense? So I'm going to take, because r equals 1/4 h, I'm going to plug that in for r right there, because that's what it equals. So now I have v equals 1/3 times pi times 1/4 h, the quantity squared, times h. Does everybody see where that came from? Okay. So then we have, if I stick ones under all of this, and I'm just looking across the top, I have pi on the top, and then some ones, and h squared and an h. So I really have pi on top, and I have an h cubed. On the bottom, I have 3 times 1 times 4 times 4 times 1. That 4 is also squared. 3 times 16, I believe, is 48. So we have pi over 48 times h cubed. This is the equation that you're going to derive. Questions so far? Okay, let's take our derivative. So dv over dt equals, I'm going to take 3 times this guy right here. You're going to get 3 pi over 48, which reduces to pi over 16. I'll say that again. 3 over here would be 3 pi over 48, which reduces to pi over 16. This h, we take the exponent down by 1. And now we need the derivative of the inner function, which we don't know, so we say dh over dt. Now let's plug in all the stuff we know. We know that dv over dt, they told us was 8. Pi over 16 is just pi over 16 times. They told us to plug in a 2 for h. Don't forget to square it. And we're looking for dh over dt. I'm going to pretend, let's see, not pretend, but this is over a 1. So I'm going to go ahead and cross cancel some of this to make it easier in my brain. 4 goes into 16 4 times. 4 goes into 4 once, because that's really a 4, right? So I really have pi over 4 right here. Multiply both sides by 4, and you get 32 equals, there's still a pi there, actually. Well, I'll write it so you guys, so people know what's going on. Divide both sides by pi. What's our label? Feet per minute. You can leave it like this, or if you've got a calculator, then you could just turn that into a decimal and take either answer. It doesn't matter. Just make sure with that decimal that if you round it, that you're rounding correctly. Questions? How do you feel about word problems? Do you guys think you could probably be okay tomorrow? Okay. What else can I tackle for you?
4.
4 it is. Everybody look at number 4. I like the way that this worksheet was set up so that it wrote it like this. Please be aware, though, on a test or an AP test or whatever, you might see it written like this. And some of you guys may not do so hot, just mentally it kind of makes it a little bit more complicated looking like that. I would rewrite it like this so that you don't make any mistakes. Just a thought, just a suggestion, you do what you want with that. Okay, what I have here, guys, is we've got two factors. So what am I going to have to do to take a derivative? Okay, you're going to do product rule. So here we go. The first factor, we just write it like normal, don't do anything to it, times the derivative of the second. So the 3 comes to the front. Leave the inside alone initially. Bring the 3 and subtract 1 off of it so we have squared. Now I need to take the derivative of the inside. The derivative of sine is cosine. Leave the 2x alone for now. Now we need the derivative of the inner function. What's the derivative of 2x? So now we have first times derivative of the second. Don't do all that work and then think, great, and then just simplify it and be done. You still have the other half of the product rule. I think when you go fast and you're kind of nervous for a test, it'd be really easy to forget the other half. Please don't forget the other half. First times derivative of the second plus the second piece, the second factor. Let me scooch out so you can see this. Times the derivative of the first. What's the derivative of x squared? 2x. Okay, so let's rewrite it and kind of make it pretty. I've got a 3 times a 2 times an x squared. So I really have 6x squared here. Times sine 2x, the quantity squared, cosine of 2x, plus, I'm going to put this 2x in the front because that's what we're supposed to do. And the sine of 2x is cubed. I think also I might take this a step further. What would you guys want to do on this, but take this a step further? Yeah, we have a couple of let's take out 2x and sine 2x squared. Because there's 2 here and 3 here. So when I do that, 6x squared divided by 2x is x, right? You with me? No, I don't know why. How about 3x? Sorry. I was thinking ahead. I wasn't even listening to myself talk. I was like 2 steps ahead going, wait a minute. I just pulled these out of that and that. So 6x squared divided by 2x is 3x. If I take out sine of 2x, the quantity squared out of this, that's what it is, so we're good. And then cosine of 2x is left. Plus 2x divided by 2x is 1. And if I take out 2 of these guys, I've got 1 left. No, it's not cubed. Sorry. Again, I'm thinking ahead. Because I think I don't like this. Something's up.
Okay, can you explain the second and third step?
Okay, so here I said x squared times 3 times 2 is 6x squared. And over here I just brought the 2x to the front.
Yes.
And then I said I'm going to take a 2x out of this and a 2x out of this, and I'm going to take sine 2x squared out of this and sine 2x squared out of this. And this is what I was left with. However, I'm not really loving this.
So you can do that?
Yeah.
Mm-hmm.
So how do you know, like, when you multiply x squared and 3 and 2, why did you multiply like x squared and 3 and 2x?
Because this is just a 2.
So you just go with the constants.
Yeah, you can multiply your constants together, and then,
X squared.
well, you know that 3 times x squared is 3x squared. So 3x squared times 2 is 6x squared. You know what I'm saying? However, this isn't matching up. Something's up. Hold on. Okay, we're good. Questions on 4? Okay, what else? 8? So number 8, let's see here, where are we? 7, oh wait. Oh, I know I was looking at the wrong paper. Got it. Okay. Sorry, these don't match up. X sine 2y equals x cosine y, and it says to use implicit differentiation. When it says implicit differentiation, they're saying basically that you're going to have to find the, you're going to try to get that y prime piece by itself, is usually what it's talking about. It says find dy with respect to x, so the derivative of y with respect to x. So we've got 2 factors and 2 factors. You're going to have to do the product rule twice. So we have first times the derivative of the second. What's the derivative of sine? Cosine. So I have cosine of 2y. Now I need the derivative of the 2y, which is 2y prime. Good. I'm going to stick that in the front. Does that freak you out if I do that? So it was x times cosine of 2y times 2y prime, but if I write it out here, it's going to look like it's cosine of this whole thing, and that's not the case. You know what I'm saying? So I took the 2y prime and I stuck it right there. Is that too confusing? Should I not do that? Everybody okay? Plus the second term, or second factor, times the derivative of the first, which is just 1, equals first times the derivative of the second. What's the derivative of cosine?
Negative cosine.
Okay, I'm going to put my negative in the front. Sine of y. Now I need the derivative of the inner function. What's the derivative of y? I'm just put dy dx or y prime. Plus the second factor times the derivative of the first, which is 1. So that is our product rule equals another product rule. Now what do I need to do? Yeah, get all your y primes on the left and get everybody else on the right. So I'm going to add xy prime sine y to both sides. So that I have 2xy prime cosine of 2y plus xy prime sine y equals, I'm going to subtract my sine 2y from both sides. So I have cosine y minus sine 2y. Everybody with me? So these guys go to the right-hand side because they don't contain a y prime. These guys go on the left because they do contain a y prime. Now that they're on the left-hand side, what do I do with them? Factor out the y prime. Logan, question?
No, so you just kind of like switch places pretty much with this x, y, sin, y, and
Yeah, just make sure you're subtracting, actually. So we take out a y prime. That leaves me with 2x cosine 2y plus x sine y.
Take out xy prime.
You could, but the whole purpose of doing this, Nick, is so that we can get y prime by itself. So yes, you would factor that out if you were just factoring for the sake of factoring, but the point is to get the y prime by itself. Great question. All right, y prime's kind of hanging out. What do we do? Divide by that big mess. So y prime equals cosine y minus sine of 2y over 2x cosine 2y plus x sine y. Pretty. Questions?
we take off points if it's 10.
It needs to be simplified. That's as far as I go.
Yeah,
10. Okay, number 10. Find the slope and tangent normalized curve. Okay, so xy squared equals, oh nope, minus xy, my bad, sorry, that's a big minus sign, equals 0, and it's at the point 1, 1, and it's talking about finding slopes of tangent and normal lines. So if we're finding slopes, slope, we think of derivative fancy for slope, so we find the derivative of these, and yes, we've got product rule minus another product rule. So for the first guy, we have first times the derivative of the second, which is going to be 2y prime, yes, plus second times the derivative of the first. Derivative of x is just 1. Now this next part, write this down so you can kind of see this. If you're trying to find the derivative of this, you need to decide right now which way you want to go and stick with that method. You either need to say minus and then do the product rule for the x and the y piece, or you need to say this is one factor and this is a factor, do the product rule, and one of those winds up negative. Actually, they both end up winding up negative, probably. So that negative gets distributed either way. But don't mix up the methods. It's really easy when you're going quickly, or if you're a little bit nervous, to screw this up. Even I've done it. So on this little guy right here, if I'm going to go ahead and approach it, and I'm going to say that this is one factor and this is another factor. So product rule, I say, I'm adding the product rule here. I've got first times derivative of the second. Well, my first factor is negative x times the derivative of the second, which is y prime, plus the second factor is y times the derivative of the first. What's the derivative of the first? Negative 1. And so that's kind of where that mistake will take place, is right there. So be careful. If you treat this as a factor up here, then you treat it as a factor back here. And so that's times negative 1, which I would stick in kind of right there. And then we have equals 0. So let's clean this up and make this look a little bit better. We've got 2xy prime plus y squared minus xy prime minus y equals 0. Now what? Yeah, you can plug in your numbers. You can get y prime by itself, but you're making more work for yourself, and you've got a greater chance of creating some mathematical errors. So we could go ahead and we could put in our x's and our y's now. And because I'm just kind of talking you through a review, I'm actually going to write all of this out. So 2 times x is 1, y is 1, y prime is just y prime. Y is 1, so I have 1 squared, minus x is 1, y prime is y prime. Don't get going so fast or be so nervous that you don't see that little y prime. That's a prime, so you don't put a 1 there. Minus y is supposed to be a 1. So I've got 2y prime plus 1 minus y prime minus 1 equals 0. My 1's are going to cancel. What's 2y prime minus 1y prime? So they're telling us that the slope at 1, 1 is 0. So we go ahead and write the equation, right? Read the question. Find the slope. It doesn't say to give me the equation of the line. So you would just say in the first blank, you would say that the slope was 0. Or you could say y prime equals 0, either way. In the second line, they want to know the slope of the normal line. What does that mean? Perpendicular. If the slope was 0, what's perpendicular to that? Undefined, because the 0 was on top. Once the 0 goes to the bottom of a fraction, it becomes undefined. Now, just curious, if number 10 had said to find the equation of the tangent and normal line, do you know what to do with that if you get 0? Okay. If you plug it into the equation like you normally would, you'd say y minus the y they give you equals the slope you got times x minus the x they give you. You work all this out, the 0 stuff's going to go away. You add 1 to both sides. You have y equals 1. That is the equation of the line, which makes sense. At the point 1, 1, regardless of what that graph looks like, who knows, they say that the slope is 0, so it's a horizontal line. The equation of a horizontal line is y equals a number. And they gave you that number. It was 1. So y equals 1. Now they want the equation for the normal line. What's that going to be? X equals 1, exactly. The equation for a vertical line is x equals a number, and they tell you what the number is right there because it goes through that point. So it's going to be x equals 1. So if they ask for the equations, and they didn't, but if they did, that's how you would find those when they're funky like that. Chances are in your test, it'll be something like, you know, a fourth and then -4 or something for your slope. But just in case, that's kind of what it would look like. All right, other things. What else can I do for you? 19? 9? Do we have a 19? Did I just make that up?
Yes.
Yes, I did. Number 9. Ah, yeah. This is good. I'm glad you asked this one. So we have x squared plus y squared equals 16. They want y prime and double prime. They want first and second derivatives. So, first derivative. Now, if you wanted to get y by itself initially, you can. You're kind of making more work for yourself, but it doesn't really matter. So we've got 2x. Now, do I need to put x prime or dx over dt or anything like that? No, they say implicit differentiation, which kind of translates to just leave the x's as they are. Plus, what? Good, 2y prime equals what? Good. At this point, some of you have been getting y prime by itself and some of you haven't. You're going to have to in order to get your second derivative because they ask for this for the first blank. So we say 2y prime equals, subtract 2x from both sides. Divide both sides by 2y and you wind up with negative x over y. So that would be your first blank. But now we need the second derivative, so we got to keep going. I see a fraction. What in the world do I do with that? Quotient rule, Booker T minus Taco Bueno. So we say bottom times the derivative of the top, which is -1, minus the top, so minus negative x, times the derivative of the bottom, y prime, over y squared. Okay, all done, right?
No.
Now what do we need to do? Right, you've got to take this little guy here and plug him into that y prime. So I have negative y plus x times negative x over y squared. So I really have a negative y, actually I'm going to put a minus, minus x squared over y. Does everybody see where I got that? Over y squared? Now here's the thing, I know I'm gonna need common denominators anyway, so I want there to be a y on the bottom over here, so I'm gonna stick a y on the top there. So now I have y squared on top and y on bottom. Alright, if I put those together, I'm gonna have negative y squared minus x squared over y divided by y squared, which means multiplied by 1 over y squared. Right? I heard it. Somebody said cubed. Also, when I make this cubed on the bottom, now if you just left it as negative y squared minus x squared over y cubed, I will take that as a simplified answer. Your professor in college might not. Because if you take a negative out of the top, looks like that. And we were told what this was. If you look in the beginning, it equals 16. X squared plus y squared equals 16. So your professor might really prefer negative 16 over y cubed.
On the test, you would accept the answer.
Mm-hmm.
Well, hold on. Where did you get 16?
Because x squared plus y squared in the very beginning is 16. Good question. Okay, what else?
How did you change it to be negative y squared?
I took a negative out of both of these, Nick. So the negative is now on the outside. So this piece right here was 16. So it's negative 16. Do what? It was, actually it was negative y squared and negative x squared?
Oh.
Good question. Yes? Sure. Number 5. Surprised nobody asked me about number 3. It's your review, it's fine, but. Alright, number 5. Yes, this is a good one. Mostly because I think you guys have forgotten some tricks. Cosecant cubed 4x. Looking for that. Alrighty, here we go. This is a peanut pretzel M&M. Please don't forget that. For some of you, tomorrow it would be very smart to rewrite a problem like this so that it looks like this. It means the same thing, but it might be a little bit easier. It's kind of less thought for most of us. So when we take our derivative, outer function first, the hard candy shell, and I get 3 times, leave the inside alone, and then make it squared. Now take a derivative of the inside. So now we've gotten to the chocolate. What is the derivative of cosecant? Negative cosecant 4x. Cotangent 4x. If you don't know that, note for tomorrow. So we dissolved, we derived the hard candy shell, the chocolate, and then inside of that we have a pretzel. We need the derivative of 4x now, which is 4. Now we need to clean it up and make it kind of pretty. Or we could go ahead and put in the pi over 6, but that might make us crazy. So let's just make it better. I've got a negative and a 3 and a 4, so I really have negative 12. You with me? And then I've got cosecant 4x. Whoops, if I could spell it, it would help. Sorry. Cosecant 4x. And I've got 2 here and 1 here, so I really have 3 of them. You see where I got that? And cotangent 4x. Everybody with me? Nope. Did somebody say nope? So I took negative times 3 times 4 and got 12, negative 12. I've got 2 cosecant 4x's and another cosecant 4x, so I have 3 of them. Because all of these are being multiplied together. Because this means times. You're not subtracting it, you're multiplying. Because it means negative 1 times cosecant 4x. Does that clear that up? It's on the inside.
I thought negative cosecant 4x cotangent 4x was 1.
It is, but it means negative 1 times cosecant 4x times cotangent 4x. So you're just multiplying a whole bunch of stuff together. You've got 3 times this guy times this guy times this guy times this guy times this guy. You're just multiplying everybody. Does that make sense, Nick? Kind of. All right, let's replace the x with pi over 6. Pi over 6. It's been a while since we've seen that. How many degrees is that? It's 30. But we've got times 4 here. So let's see. We really have negative 12 times cosecant. 4 pi over 6 is 2 pi over 3. And that's being cubed times cotangent of 2 pi over 3. Now, if you get stuck tomorrow and something like this shows up and you're like, I don't know what to do, I have to quit. No, you don't. Draw yourself a little grid. What's 180 degrees? Pi. Or you could think about that as 3 pi over 3, right? Because isn't that pi? So if I divide this into 3 equal parts, 180 divided into 3 equal parts would make this one 60, and this one 120, and that one 180, right? So if it's 2 pi over 3, 2 of the 3 are colored in. So we're at 120. Does everybody see how that works? So 120 degrees, basically. If this is 120, this is 60 here. If you need to draw the little triangle, draw it. It's a test. You don't want to miss stuff. 60 degrees. Here's this. Do you remember your ratios for 30, 60, 90s? 1, 2, radical 3. Yes?
Yeah.
Cosecant is the reciprocal of what? Reciprocal of sine, and sine is what over what? Opposite over hypotenuse. So instead of opposite over hypotenuse, we have hypotenuse over opposite. So it's 2 over radical 3. But, remember this? All students take calculus. So is cosecant positive or negative in this quadrant? Positive, just make sure you know that. It wasn't going to catch you this time, but it might on a test or something. Cotangent of 2 pi over 3. Well, we've already kind of got it drawn out. Tangent is opposite over adjacent, so it's got to be adjacent over opposite. So 1 over radical 3. Any questions so far? I really think the hardest thing about this one is the trig part. Yes, thank you. Cotangent would be negative. Thank you for picking up on that. Second quadrant would be negative. Thank you, thank you. Now we can kind of start to take this thing apart, or put this thing together. We've got negative 12. 2 cubed is 8. Radical 3 cubed. Do you know what that is? Radical 3 times radical 3 times radical 3. So it's 3 radical 3s. And then we have times negative 1 over radical 3. Let's multiply all of our tops and all of our bottoms. Actually, I'm going to reduce. 3 goes into 3 once. 3 goes into this guy 4 times. Negative 4 times 8 times negative 1 is what? Positive 32? Because Carson, you've got a negative and a negative. On the bottom, I've got radical 3 times radical 3, which is? Whew! I think we did it. That was a lot. Questions? Okay. Let me give you the rest of the answers so you'll have them to study. Okay, let's see here. And the answer key, all the numbers are kind of off, so don't let that throw you. It says number 2, but it means number 1. So here's the answer number 1. Even though it says number 2, it's number 1. We already did number 2 together, and it's still on the board. Number 3, here's the answer for that one. It says number 4, but it means number 3. Here, I'll just cover that up. There's number 3. I'll zoom in. Did we do 4 together?
Yes.
Okay, 4 is done. Oh, whoa, sorry. Did we do 5?
Yes.
Did we do 6? Okay, 6, 4th root. Oh, it's this one. Here's 6.
What's that thing over there too?
It's a screw up. It needs to be whited out. Sorry. Did anybody in here already have this answer on their paper? Good. I just asked because I got a different answer, but I'm pretty sure it's because I was busy watching Netflix. Pretty sure I wasn't as focused as I could have been. I kind of got sucked into Royal Pains. It's not even that good of a show, but I started it, now I have to finish it. Next problem. Did we do this one together? Number 7? No, and is this? That's not even it. Hold on, I gotta find it. Okay, here's 7.
So if all the sides are flipped, it's still red though, correct?
Good question. We did 8 together. Did we do 9 together? Did we do 10 together? 11? Okay. number 5 on this page. X, Y, tan X. Negative a third and 4. Negative a third and 4. And I did all the last page for you. So that should set you up for tomorrow. Study, study, study.